Currently, they are not, but and recently we will share them with the community. We have already shared.
Thank you very much for the introduction, and sorry for the technical problem, but the ambassadors were looking for my presentation. So this is this, and how to push the slides. No. Okay. So first of all, I would like to thank the organizer. It's my, let's say, honor, and I'm very happy to be here. Second time in Mexico. So thanks to the organizers, to Jupiter, to the university, and so on. The title of the talk is a large language model and GIS science, and what should we expect from this kind of big evolution. I have been addressing this subject for now a few months. The subject is new. And the idea behind this talk is to say, as a scientist, what kind of questions the emergence of artificial intelligence can bring to the general issue of geographical information science and systems. What kind of contribution should we expect from this big sort of revolution? Because I think it is a revolution. But also addressing not only the potential contribution of large language models, but also the challenge and problems we should be aware of, and addressing, of course. What I would like to do is to start with, and especially as we do have some students in the room, to introduce some basic principles about large language models, how they work and so on. And also to look back to the past, because hopefully, as you will see, the emergence of AI in GIS science has been a sort of a recursive process over the past 40 years. It started 40 years ago at the age of, let's say, artificial intelligence was booming. And I will come back to that because I think we can learn from the past. Anyway, I will introduce, so taking back to the 80s in the past millennium, how AI has been already contribution to geographical information science. Then following up to large language model, introducing a few principles that make now large language model quite successful in comparison to GIS science or system principle. And the key and interesting question I would like to deal with you, what should we expect from large language model in relation to GIS science on the one hand, and on the other hand, what can GIS science bring to large language model? And finally, discussing a few issue, challenge, and problems we have to deal with. I mentioned that, but in the 80s, geographical science was also in a let's say in a big change. It was the end of a quantitative geography period, and geographers, scientists were looking for alternative methods to deal with complex geographical phenomena. And at that time, the lack of what we can say solid theories to model complex space and time phenomena, people and scientists were looking for, at that time, expert systems were raising up. And the idea, well, could we think about expert systems, neural computing, bringing, let's say, new ways of dealing with complex geographical information. This was not very much successful, especially regarding contribution of expert system. Neurocomputing was not either very much successful. It was a bit successful in the way formal spatial reasoning has been developed. This was the time of queries, spatial query languages and so on, and the development of algebra. So in fact, AI was, let's say, more or less contributing to GIS, but not too much. And then time was going on, and large language models somehow, let's say 4 or 5 years ago, started to become a new area, and I would like to come back to a few basic ideas. What about large language model? Is also a sort of artificial intelligence framework from technology, where the idea is to, can we provide a way of understanding the way human beings are processing information, especially using human language. And the idea was, as far as the human brain is made of neural net connecteds, and let's say processing information in different ways, the idea was, as a basic task, is to identify in any language structure the way the information is processed. For example, when there is a sentence, the sky is something, as human being, if I say to you, the sky is, you will already provide, you say, well, the sky is blue. Because our knowledge, our experience, make this sentence a quite useful structure, and we understand the pattern, and our neural brain is providing the solution. So the idea, and the main idea of a large language model, is to identify in any language structure, using what we call the pre-trained language knowledge, the new word. The system is quite large. This is why we are talking about large language models. It is based on neural net. And the idea is to have a sort of very large information base. Our brain is manipulating a lot of information. And the beauty and the main advantage of a large language model is that they are processing millions of data organized in a quantitative and numerical way in order for the large language model to process the data appropriately. So this is really the main principle. So in fact, there is a sort of statistical evaluation of any pattern, then numerical representation of all the words in relation with the context. The information is processed and transformed in order to respond to any query. The turning is a sort of process that by experience and by processing the information in a sort of recursive way, a large language model is in the position of statistically, quantitatively, as the different words are connected to process any query and to deliver some information. So this is mainly the main principle. Large language models are not coming up by chance. It was a sort of very long process that started 60 years ago, and I will come back to a few landmarks that make this system nowadays very successful. The first one was not a very large language model. It was a small language model designed by a psychologist in the 60s, so 60 years ago. And the idea was to set up a sort of, let's say, a knowledge base made of pattern, sentences, and so on. And the idea was to provide a sort of method to provide a communication in between humans and machines. The subject was very much focused, and the idea was to provide some specific answers to some specific psychological problems. It was very much successful. If we look to that, and if you have been using ChatGPT, it's quite similar. The difference is the training base is very small, it is very focused, and it is not a large language model. It was a small language model. But the principle behind large language model was set, and in fact, all the further development made by Google, different labs and so on, were really based on this principle. We do have nowadays 3 categories of large language model. The very large ones, ChatGPT, Llama, Mina, and so on, which are trained on very large amount of data. There is no specific focus. We have a specific model such as ELIZA, for dealing with specific problem, a specific area. So this means that the training data set is relatively small, and I will come back to that. And the new generation is what we call a multimodal large language model, not only combining text as the level of, let's say, the training knowledge base, but also including text, image, and video. And this is rising up at the moment in the news. However, all these systems are still based on the same principle. This slide is quite interesting because when I'm talking of the training base, the way a large language model is running, and this is a key issue when we are thinking about the potential problem. The data source is made of structured and unstructured data, millions of data, and any system, can be ChatGPT, can be Llama, whatever, will define the knowledge base. And there will be some questions. I will come back to that. And then the system is processed, and then the data is coming back to you in the most appropriate form. The way it's working, there is a sort of architecture. There is the training base. There is the question you are asking to the system, and then the transformer is coming back to you with some appropriate answers. What we should notice is that all the information which is qualitative at the start is transformed in quantitative information made of nodes representing quantitative information and different connection in between the different words extracted from different sentences and whatever database representation in order to generate some responses to any query. The range of application is very large, can be about, let's say, health studies, can be about analyzing financial data, and so on and so on. This is the very large, let's say, background of a very large model. Now the question I'm interested, well, regarding the different categories, ChatGPT and the others are a general system. At the time these systems are still under development, there is another research area, which is the one on natural language processing, which is still making some progress. And this second category of developments, okay, the other category of development, which is coming from the natural language processing, is still making some progress in the way we can address and analyze textual information to derive some, let's say, sentiments, some classification on the way human beings are providing information. So this is the second category. The third one is combination of textual data, visual data, and the idea is still based on the same principle. We have a neural net. Those are the current large language model processing textual, vision, map information, and so on. For example, if there is this input, an image, this is Salvador Dali, describe this image with an emoji, this can be the output. So the difference is, in this specific case, not only the training base is made of textual data, but also with visual data, and the output can be also combining textual and visual data. So fair enough. The systems are quite efficient. We have been all using the system, but now there are some questions to deal with. First of all, in the time of decarbonation, inclusion and so on, what is the cost of using the system? Setting up a very large database at the training level, you can see an example here from ChatGPT. This is one thing. And every time we are running a query, it is costly in terms of carbon emission. This slide is quite interesting because you can see, especially to the right, the cost of training a system such as ChatGPT. Training a system such as GPT at the start is about 552 tons of CO2, is about 50 flights from New York to San Francisco. If we think about millions of people sending query to ChatGPT, you have the numbers at the bottom of that slide. It's about 20 times the 50 flights from New York to, let's say, San Francisco per month. I mention that because we are all using ChatGPT, but there is an impact, and the impact is increasing. Now the question I would like to address in relation to geographical information system and geographical information science, what can be the respective contribution? To the left, we have what large language models are efficient for, interpreting textual information, analyzing the semantic behind some sentences and very large databases, putting information in context, providing location-based information from textual data, and conversely, GIS science to the right. The question we have been addressing in our research community in relation to the very large amount of data which is coming on from the domain of geographical information system, we have the people, we have the data, thinking of the two previous presentations, we have sensors, and the range of application is very large. So it's relatively interesting from a scientific point of view as far as we consider an integration of the two scientific domains, very scientific to the right and very technological based to the left. There are some interesting questions the community is at the moment dealing with. A few examples of what can be done nowadays with large language model when applied to geographical information systems. So this is an interesting example taken from Mistral, a large language model, and a platform which is Ollama, where we can visualize from scratch and from a training database, which is the one of pharma payment to US-based physician. These can be generated from scratch. There is no GIS behind. This can be generated from scratch. Another example is that one, as far as we have a trajectory to the top, with coordinate, the idea will be to analyze these trajectories. We have 4 examples of successive large language model. To the left, no knowledge is given to the system. So the idea will be to extract some specific trajectory. The second one, we are giving an input, some specific processes, rotating and so on, and we are successively providing some chain of thought for the system to reason of this specific data. And then from a specific set of trajectories, we can extract some specific patterns. So this is currently under strong development at the moment, is from basic geographical information to extract some space-time pattern. To the right, to the top, sorry, we have another example from locations and from objects located in space and time. The idea will be to extract some qualitative information in the way the different objects are related one to the other. In this specific case, the idea is from some textual information to extract geographical information. So to the top is from geographical information, extract qualitative information, and to the bottom is from textual information to extract locations. Those are under strong development, so this is successful, but another one, the last one, which is quite interesting, is can we generate, and this is interesting for the student, can we generate some codes from large language model? This is an interesting example, a recent one. The question is just this question. Could you map the population living with hazardous waste using these data sets? So the large language model is transforming this question in a successive set of data, operation, answers to provide an output in the most appropriate form. What is very interesting in this specific example is the way the data is processed. Will come up. In the way the data is processed. Here, this is the construction from the query. The system is automatically generating a sort of knowledge graph where the objects, data from, let's say, the population and data from the waste is automatically processed in a sort of, well, using GIS, this can be the process a human being will be generating by himself. The system is automatically generating the set of operation from the data, the combination of the data to produce an output. And if we think about the way we have been using GIS, this is just amazing. This is just amazing. There is, however, no debugging. And the data is coming from somewhere. Question, where is the data coming from? The data is given as a result, but there is an issue here as well. Fair enough. Is everything perfect? No. It is not perfect. Challenges. There are many. There is a list, and then I will give you some example. When you are asking a question to a large language model, there is the question of how should I write the question in the most appropriate way? Question, data privacy and security, where is the data coming from? We don't know, the system knows. Training, the system is trained, but it is a sort of static system. If you are prompting questions to ChatGPT or any other large language model, it will not be in the position of learning from what you are changing with him. I will give some example. Data diversity is an issue, especially regional diversity. The system is not always scalable in computing terms. There is no auto-validation. How can we interpret the result? Wow. We have beautiful maps, we have beautiful outputs, but interpretation and explanation is an issue as often in artificial intelligence. And in fact, the word artificial intelligence is wrong because there is no intelligence and it's difficult to interpret. So reasoning capability from a computing point of view are very limited. It is just combination of data using neural net, but there is no reasoning capability. Lack of disruption. This is an interesting one. The system is giving you back what he has as a knowledge base, but it's very difficult to extract disruptions. The system is not in position of making mistakes, and sometimes we learn about mistakes. Ethics and diversity is another issue. There is no standard because large language models are driven by the big industry, and there are some sustainability issues and education to deal with. There are many bias in large language model that sometimes reflect gender, race, and other forms of bias. So there are some ethics problems to deal with. So trust is an issue, and I will introduce some very small example from what we can call a geopolitical bias. Ceuta is a city, a Spanish city in North Africa, in the north of Morocco. If you ask the same question in Arabic or in Spanish, the answer is different. If you ask the question, does Ceuta belong to Spain? If you ask the question in Spanish, the answer, roughly speaking, is yes. If you ask the question in Arabic, the answer is different, as you can see. Ceuta did not become a natural part of Spain, blah, blah, blah. First example. Another one, which is semantically, conceptually very much interesting. This is Paris, this is Luxembourg. Luxembourg is located northeast to Paris. If you ask the question to ChatGPT, which direction to take from Paris to Luxembourg, the answer is correct, northeast. If you ask the question to Llama 2, the answer is southwest. What is the reason behind this response? The problem is those systems, large language model, and this is a big one, they are not in the position to reason at different levels of abstraction. They are not in the position to have a global view and having the ability to reason at different levels. And if we look, let's say, having a sort of zoom, as you can see, when starting from Paris, and the system Llama 2, when started to Paris, is starting from the city center. And in fact, it's not wrong to say that when starting, the first step will be southeast, southwest, sorry, as you can see to the right. So somehow it's not wrong at this very local level, but globally it does not have the capability to reason at another level of abstraction. Okay. Another one where large language model, they do have a really big problem with spatial qualitative reasoning. If you ask ChatGPT, could you draw for me a polygon which is in another polygon, it will give you different answers which are not appropriate. More complicated, you are giving a description of this, let's say, Venn diagram, which is right and to the right. After many attempts, it will be not in the position of giving the right answers from the text information. So currently, in short, large language model, when applied to geographical information, they don't have the capability to reason at different levels of abstraction, and they do have big problem to reason in space, in spatial qualitative term. How to evaluate those problems? A few labs are developing metrics, but metrics are quantitative, so it's not always appropriate. And one issue at the moment is to think about integrating human logics. in the loop. It's a big issue because somehow large language model as standalone system, it is a big issue. How to mitigate this BR is to interact at the training level, and we ask the question is how can we integrate with these big companies? Time is not completely integrated in those systems. How to extend the training model with additional geographical data in order to provide sufficient diversity is another issue. How to remove inappropriate geographical data, updating the data and so on, this is another issue. The prompt level, I mentioned that before, is a big one. We should train expert users to ask the question in the most appropriate way. And one I'm currently working on is how can we integrate different large language model in a sort of coordinated platform that can learn one from the other. This is an interesting one. Coming back to human beings, large language models are very good because they are based on neural nets, as we are. They do have a knowledge. They have a training process, but relatively limited. Those are the similarities, let's say, neural nets and a knowledge base. However, we still have what we call biochemical processes, which is not made on purely quantitative information. Large language model is only operating mathematical computation without any consciousness or subjective experiences. Human memory is associative, contextual, emotion-based, sensor-based, and we do have all of us a personal history and the capability to interact with others. We do have intuition, personal judgment. We make mistakes, and those systems do not make mistakes. And I think this is a big limitation. The future. Looking to the future, there are some great, fascinating, scary direction. As far as we think about a large language model being autonomous, be associated to a sort of sensor-based environment, robotic environment, we might have some independent sensor-based autonomous large language model integrated within a robotic environment. So think about autonomous robots that are connected to large language model capability. This is becoming scary. Integrating also chemical process in order to bypass the quantitative limitation of the way computers are running. And we can think about computing as well. If we think about learning capabilities, a system that will be in the position of learning from the questions a human being will ask, and then the Turing challenge will be fulfilled by the way. And again, reasoning capabilities. Wow, if we have all of that integrated in those systems in a few years, and at the time those systems are under development, we can be really scared about that. So thank you very much.
Thank you very much for your presentation, Professor. So we will begin with the question session. Anyone has a question, please?
You mentioned that there's some environmental impact around asking queries to these systems. So, what are the criteria or factors that were evaluated or assessed to get these numbers? about the carbon emissions.
Sorry, the micro is sort of interrupted. Could you speak without the micro? Okay. The training level, let's say, designing a large language model such as ChatGPT involve compiling the data, involve generating the neural net, involve fine-tuning the system, and all these steps are costly because the computers, very large computers, are running, keeping the data, storing the data, and so on and so on. This is the first level. So this can be simply translated in kilowatt hours, and this has been, as you can see here, approximated for ChatGPT. What is interesting here is that differences in between text classification, organization of the data, the token classification, where all tokens are translated to numerical values, and then when the system is getting into image generation and so on, you can see that the processors are getting more and more expensive in terms of kilowatt hours. It's a sort of electricity impact. This is one thing. The other part of the story is when the system are interacting with the users. When you are sending an email, there is a cost. When you are asking a question, there is a cost. You send your question and the system is processed and sending back your question. When there are monthly of people using the system, there is an environmental impact. So the question will be, well, we should be aware that there is a cost. And now in science, the community is thinking about every time we do some research, what is the cost in the environment? When we are traveling, there is a cost. And it's good to have comparison figures. And this is increasing. It's just to be aware of what we are doing and the cost for the society. If you are using your GIS system on your own, this is one thing. If you are using this kind of system, it's good to have the figures and to be in the position of comparing the two worlds, the old one and the new one which is likely to kill the old one. If you think about the speed of the developments of this system, you know what is fascinating is that now the system can generate programs. But there are questions, but this is fascinating.
Thank you so much for the awesome presentation. I have one question about, that when we are putting any information into ChatGPT or any other, OpenAI systems, whatever you put in, garbage out at some point, right? And reproducibility of any research is a major issue. So what would be your kind of advice or points on what academia can play a role in mitigating that to a degree?
Well, surely academia can play a role, for sure, in the way addressing these questions. First of all, regarding yes, this is another interesting one. Regarding reproduction of research, is that your question? Regarding reproduction of research, if we take this example, the example is relatively simple. The system is generating this graph, that is the different steps used to produce the result. That one is interesting because not only the output is given, this is from a lab. The lab is producing this output by using this sort of large language model extended by geographical capability, fair enough. What is interesting is that in this specific case, the system is not only producing the output with textual additional information and the different steps extracted from the knowledge graph production, fair enough. But this is the ideal one. If you have a ChatGPT GIS designed under the same principle that ChatGPT is designed nowadays, you will just have the output. So question will be how to reproduce this output, question, how to update this output if we have new information, question. If we think about the first presentation this morning about remote sensing data, if you have new remote sensing data, if you want to send that data to the system, the large language model system, it will not accept. So it's not an interactive system. If I was tough, I will say that a large language model is a dead system with no interaction capability. You cannot, as a user, train the system and provide additional information. What is done cannot be reproduced with small updates on the information. No way. The system will be not in the position of interpreting and explaining the result. The first speaker was explaining. But, you know, large language models are already used to produce research papers. This is scary. And this happened. 4 papers have been produced by a large language model, reviewed by pairs, and considered as a valuable research paper. Regarding the Turing test, an experiment has been done a few weeks ago by putting in a room 40 persons answering questions. The other room, ChatGPT was answering questions. And then a panel was trying to make a difference in between the two groups. They didn't identify which group was the ChatGPT group and the other group, the humans. So now it is considered that this ChatGPT 4. something has complied the Turing test, where human beings were not in the position of making a difference in between ChatGPT and human beings. So this is scary, you know. But it's exciting. As scientists, it's exciting, and not mentioning the impact on education, but this will be for tomorrow.
Thank you.
Good morning, Professor. Thank you for your presentation. Regarding the public institutions and other policymakers, do you think or do you consider they will be soon ready to interact with the LLM systems to implement, for instance, social, cultural, or even health politics? Let's say, for instance, urban planning supported on this kind of technologies?
Well, this is a good question, Willington. In fact, if we think about the way local institutions are interacting with researchers nowadays, and this is already the case in some professions where directly reports, especially in law or financial institution, ChatGPT and others are already bypassing consulting companies and so on. This is one thing. If we think about our domain, why not thinking about a transportation administration, for example? Why not thinking an environmental institution, having ChatGPT train people, directly asking questions about urban development, transportation problems, transportation development scenarios, and so on, directly with those systems. So in fact, we might have, in some cases, local institutions directly interacting with ChatGPT. But there is another issue I would like to stress. This is not a question, but I would like to stress this, because with one example I would like to give, the training data. In China, there is a recommendation at the moment by the national body that is assessing to which degree data sources are compliant with the party, in short. This is just one example, right? This is the key issue. This is the key issue. The knowledge base is coming up from somewhere, can be trained. When you train a knowledge base, you give values to the data. This one is good, this one is important, this one is in relation to that one, and this is done in millions of operations. But we don't have any knowledge about the way it has been done. We don't have any clue about where the data is coming from. If I ask you a question, you will give me an answer. I don't know where is your answer coming from. This is the way it is working. So, where is the data coming from? We don't know. Who is training the data? We don't know. How much value is given to this data? We don't know. How much important is this data? We don't know. Can we update this? No way. Can we ask Google for more information? No, no way. Could we implement our own algorithm within the system? No way. Could you interpret the data for me, explain the data for me? No way. So we are somehow stuck, right? Anyway, it's fun.
Unfortunately, we don't have any more time for questions, but please talk with our speakers, as they didn't come to Mexico every day. So we want to acknowledge the excellent conference given by Professor Christoph by providing this certificate. We also want to express our gratitude by giving him a small gift. Thank you very much for your time. Now, we will continue with the next presentation.